Hello my friends and welcome to my channel. In this video we are going to be going through the specimen paper for 2020. Don't forget to visit my website waltermess.com for more learning resources. So let's get started. Question number 1, part A. Given that f of r is equal to 1 over r plus 1 bracket r plus 2, show that f of r minus 1 minus f of r is equal to 2 over r of r plus 1 of r plus 2. Okay, so here we are saying f of r minus 1 minus f of r, and this is going to be equal to, for f of r minus 1, we're substituting r minus 1 for r here. So it means that we'll be having 1 over, that's r minus 1 plus 1, which is r, and it's bracket r minus 1 plus 2, which is r plus 1. And it's going to be minus f of r is this fraction that we already have. So it's 1 over r plus 1 of r plus 2. So next I'll find the common denominator, and that's the LCM of these denominators. So that'll be r of r plus 1 of r plus 2. And now I'll divide r of r plus 1 into this denominator. And if we do that, we'll be left with r plus 2 as the quotient, and we multiply that by 1. So we'll just be having r plus 2, and it's minus, and we divide this denominator, r plus 1 bracket r plus 2, into the LCM, r of r plus 1 of r plus 2, and we are going to be left with r as the quotient, and we multiply that to 1, so we get r, so that's minus r. So next, r minus r is 0, so on the numerator we'll be left with a 2, so that's 2 here, and that's over r of r plus 1 of r plus 2. So this is what they wanted us to get. So we can say hence shown. Let's go on to part B. On part B, the question goes, hence find the summation from r is equal to 1 of the form 1 over r of r plus 1 of r plus 2. So from what we've been given in the question, I'll say consider the summation from r is equal to 1 up to n, and we'll start with the one for 2 over r of r plus 1 of r plus 2. So that is going to be the same as the summation from r is equal to 1 up to n of the form f of r minus 1 minus f of r. So let's work on that. So for that, it is going to be the summation from r is equal to 1 up to n of f of r minus 1. Now f of r minus 1 is 1 over r of r plus 1. Remember, we had done that in part A. For f of r minus 1, we had gotten 1 over r of r plus 1. And it's minus f of r, which is 1 over r plus 1 of r plus 2. So we're going to use the method of differences. So we are going to say when r is equal to 1, then we're substituting 1 for r. So that will be 1 over 1 of 1 plus 1, which is 2, and that's going to be minus 1 over 1 plus 1, which is 2, plus 1 plus 2, which is 3. So basically this is 1 over 2 minus 1 over 6. Next, when r is equal to 2, we are saying that that will be 1 over, substituting 2 into this, we get 2 of 3 on the denominator, and it's minus, and substituting 2 here, it will be 2 plus 1, which is 3, of 2 plus 2, which is 4. And what that's going to give us is 1 over 6 minus 1 over 12. So this is going to continue going. We can do r is equal to 3, and by the same pattern, it will be 1 over 3 of 4, and it's minus 1 over 4 of 5, which is 1 over 12 minus 1 over 20. So we can continue all the way up to the second from last term, which is r is equal to n minus 1. So if r is n minus 1, substituting that for r will give us 1 over n of n minus 1. And it's going to be minus, and substituting it into this, we get 1 over n of n plus 1. And when r is equal to n, which will be the last term here, then we'll be having 1 over n of n plus 1, and it's minus 1 over n plus 1 bracket n plus 2. So this is what we'll be having here. So if we are going to add up the terms in the series, then minus a 6th will add up to a 6th. Minus a 12th will add up to the 12th. So all this will give us 0. So minus 1 over 20 will add up to another 1 over 20 to give us 0. And so will this here. And minus 1 over n of n plus 1 adds up to 1 over n of n plus 1 again to give us 0. So the terms remaining in the series after adding up all the terms will be a half. So let me write that down. That's a half minus 1 over n plus 1 of n plus 2. Okay, so that's what we get remaining after the method of differences. So remember, this was an expression for the summation from r is equal to 1 up to n of 2 over r of r plus 1 of r plus 2. So the question demands that we find the summation from r is equal to 1 up to n. So we're saying therefore of 1 over r of r plus 1 of r plus 2. So we can get that by dividing this by 2. So if we divide this by 2, it's like we're multiplying a half both sides. So if we multiply this by a half, we are going to get a quarter minus 1 over 2 of n plus 1 of n plus 2. So this is the answer that we should get. Let's scroll down to part C. The question goes, deduce the value of the summation from r is equal to 1 up to infinity of the form 1 over r of r plus 1 of r plus 2. So we can say this here is the same as the limit as n approaches infinity of, from what we got right above, that's of a quarter, minus 1 over 2 of n plus 1 of n plus 2. Now a quarter is just a constant, so we have it right here. And it's going to be minus, and for this, as n approaches positive infinity, that is, as n becomes significantly large, then this fraction here will tend towards 0. So we are going to get a quarter for our answer right here. And that's how we answer part C. So we're done with question number 1. We can scroll down to question number 2. Question number 2. It is given that phi of n is equal to 5 to the power of n of 4n plus 1 minus 1, for n is equal to 1, 2, 3, and so on. Prove by mathematical induction that phi of n is divisible by 8 for every positive integer n. So I'm going to start by saying, let p sub k be the proposition that phi of n is divisible by 8. And that's for every positive integer n. So therefore, proving our best case, we'll be saying phi of 1. And phi of 1 is 5 to the power of 1 of 4 of 1 plus 1 minus 1, which is 5 of 4 times 1, that's 4, plus 1, that's 5, and it's minus 1. So it's like 25 minus 1, which is 24. Now 24 is divisible by 8, and so we can say P sub 1 is true. So we have proven true for n is equal to 1 right here. Next, we go on to the step where we assume that the statement P sub k is true, and that's for some positive integer k. So here this is going to mean, therefore, that phi of k, which is equal to 5 to the power of k of 4k plus 1 minus 1 should be equal to 8l, just meaning that it's divisible by 8. We go on to the next step where we are going to say now, for P sub k plus 1, let us consider phi of k plus 1 minus phi of k. So we are saying here phi of k plus 1 minus phi of k is, for phi of k plus 1, we are substituting k plus 1 for n, so we'll be having 5 to the power of k plus 1, and it's going to be of 4 of k plus 1 plus 1 minus 1, and it's going to be minus phi k. For phi k, it's 5 to the power of k of 4k plus 1 minus 1. So we can actually simplify this. So 5 to the power of k plus 1 is 5 to the power of k of 5 to the power of 1, and it's multiplying inside the bracket. It's 4 of k plus 1, which is 4k plus 4, and plus 1, it becomes 4k plus 5, and it's minus 1, and it's going to be minus 5 to the power of k of 4k plus 1, and it's going to be plus 1. So next I'll be having 5 to the power of k, and multiplying 5 into the bracket, I get 20k plus 25, and here minus 1 plus 1 give us 0. So I'll be left with minus 5 to the power of k of 4k plus 1. So from here, I am going to factor out 5 to the power of k. So I'll be having 20k plus 25, and it's minus. Here I'll be having 4k minus 1. So this will give me 5 to the power of k of 20 minus 4k is 16k, and 25 minus 1 is 24. So this is what we'll be having, and we can factor out 8. So if we factor out 8 from this, then we'll be having 5 to the power of k of, and then 8 into 16k, that's 2k, and 8 into 24, that's 3. And we can say this is equal to 8m, where m is this 5 to the k of 2k plus 3. So in other words, it's divisible by 8. So this 8m is actually for phi of k plus 1 minus phi of k. So let's write that down. So we're saying phi of k plus 1 minus phi of k is the one that got us 8m, And for phi of k plus 1, which is what we're looking for, it has to be equal to phi of k plus, in this case, 8m. That's by taking minus phi of k to the right side. So here, we know that phi of k, from the assumption, we got that to be 8l. So it's as good as we have 8l plus 8m, which is 8 of l plus m, and this is divisible by 8. Okay, so phi of k plus 1 is divisible by 8. So therefore, p sub k plus 1 is true. So we can now make the conclusion that if p sub k is true, then p sub k plus 1 is also true. And therefore, by the principle of mathematical induction, p sub n should be true, and that's for every positive integer n. So that's the concluding statement, and we are done with this question here. Question 3. The curve C has polar equation r is equal to 2 plus 2 cos theta for values of theta ranging between 0 and pi. So on A, they say sketch C. So here, just by looking at the equation, we can see that it's a cardioid graph that has symmetry about the initial line. So we can easily make the sketch. So this is theta is equal to 0, and this is pi over 2, and this here should be pi. So due to this range, it's more like a half cardioid, so it should come out more like this. So this here is the pole, and it should intercept the line theta is equal to pi over 2 here at 2, and the line theta is equal to 0 here at 4. Let's go on to part B. Find the area of the region enclosed by C and the initial line. So we are looking for the area enclosed by the graph, and that's this area here. So we know that area enclosed by a curve is found by the integral from alpha to beta of half r squared with respect to theta. Now, in this case, the equation of the curve is r is equal to 2 plus 2 cos theta. So we'll be saying area is equal to the integral, that's from 0 to pi, those are the limits, of half of r squared. In this case, r is 2 plus 2 cos theta, so it's 2 plus 2 cos theta, and that's squared, and that's with respect to theta. So we can simplify this. So it's the integral from 0 to pi of half, and for 2 plus 2 cos theta squared, we get 4 plus 8 cos theta plus 4 cos squared theta, and that's with respect to theta. So we continue simplifying. We can take the half outside, so that's 1 over 2 of the integral from 0 to pi, and that's of 4 plus 8 cos theta, and it's plus 4, and for cos squared theta, we can use this identity to take that to be a half plus a half cos 2 theta, and that's with respect to theta. So we continue, we have a half, and that's off the integral from 0 to pi of 4, and that's plus 8 cos theta, and multiplying 4 into the bracket, we get 2 plus 2 cos 2 theta, and that's with respect to theta. Next, we'll be having a half of the integral from 0 to pi, and 4 plus 2 is 6, so it's 6 plus 8 cos theta plus 2 cos 2 theta with respect to theta. So I can factor out 2 for this. So if I take 2 out, the 2 will multiply with a half to become 1. So we'll be having the integral from 0 to pi of 3 plus 4 cos theta plus cos 2 theta with respect to theta. So from here, I can now integrate. So integrating 3, we get 3 theta. And integrating 4 cos theta, we get 4 sine theta. And integrating cos 2 theta, we get a half of sine 2 theta. And the limits are from 0 to pi. Okay, so now I'll substitute pi for theta. So I'll be having 3 of pi, and that's plus 4 sine pi, which is 0. Sine pi is 0, and a half sine of 2 pi, which again is 0. So it's going to be minus, and I substitute 0 for theta again into this. So 3 of 0 is 0, 4 sine 0 is 0, and half sine 0 is again 0. So it's minus 0. So we are getting our answer as 3 pi. So that's what we get as the area enclosed by C and the initial line. Next, we go on to part C. It says, show that the Cartesian equation of C can be expressed as 4 of x squared plus y squared equals to x squared plus y squared minus 2x all squared. So we have the polar equation as r is equal to 2 plus 2 cos theta. Now what I'm going to do is I'm going to multiply all the terms by r, which means I'll be having r squared is equal to 2r plus 2r cos theta. Now using these important results, r squared is x squared plus y squared, and it's equal to 2 of r, which is the square root of x squared plus y squared, and it's plus 2 of r cos theta. Now r cos theta is x, so it's 2x here. So I'm going to subtract the 2x from both sides, which means I'll be having here x squared plus y squared minus 2x, and it's equal to 2 of the square root of x squared plus y squared. And from this here, I can square both sides. If we do that, on the left side, we'll be having x squared plus y squared minus 2x all squared being equal to 4 of x squared plus y squared, which basically is what they want us to get. So let's just rewrite that to 4 of x squared plus y squared equal to x squared plus y squared minus 2x all squared. So that's exactly what they want us to get. So we can say hence shown. And that's it for part C. Question number 4. The cubic equation z cubed minus z squared minus z minus 5 equal to 0 has roots alpha, beta, and gamma. On part A, show that the value of alpha cubed plus beta cubed plus gamma cubed is 19. So here I'll start by finding for this cubic polynomial equation the sum of roots, which in this case is minus b over a. So that's minus 1 over 1, which is 1. Then the sum of product of pairs of roots, which is c over a, and in this case that's minus 1 over 1, so it's just minus 1. Then the product of roots, that's alpha, beta, gamma, is minus d over a, and that happens to be minus 5 over 1, and that's 5. So from here I am going to make z cubed subject for this equation. So that will be z cubed is equal to z squared plus z plus 5. And since alpha is a root, we know that alpha cubed should be equal to alpha squared plus alpha plus 5, just by substituting alpha into this equation. And also beta is a root, so beta cubed is equal to beta squared plus beta plus 5. And also gamma is a root, so gamma cubed is equal to gamma squared plus gamma plus 5. So we now have this 3 equations: equation 1, equation 2, and equation 3. Now if we add up the 3 equations, that's adding up equation 1 plus equation 2 plus equation 3. Then we'll be having on the left side alpha cubed plus beta cubed plus gamma cubed equal to alpha squared plus beta squared plus gamma squared, and it's plus alpha plus beta plus gamma, and it's plus 5 plus 5 plus 5, which is 15. So we can come out with the recurrence relation equation here, which is for alpha cubed plus beta cubed plus gamma cubed, we can write that as summation of roots of the form alpha cubed, and it's equal to, for alpha squared plus beta squared plus gamma squared, that will be summation of roots of the form alpha squared, and it's plus alpha plus beta plus gamma is the sum of roots, and it's plus 15. So this is the relationship that can help us to find alpha cubed plus beta cubed plus gamma cubed. Now, first we'll need to find the sum of roots of the form alpha squared, which is alpha cubed plus beta cubed plus gamma cubed. Using this relationship, we can say that this is equal to the sum of roots squared, and that's minus 2 of the sum of product of pairs. For the sum of roots, we said that's 1, and the sum of product of pairs is minus 1. So it's like we have 1 squared minus 2 of minus 1, which is 1 plus 2, and this gives us 3. So that's what we get for alpha squared plus beta squared plus gamma squared. So we can now have our answer for the sum of roots of the form of alpha cubed, which is alpha cubed plus beta cubed plus gamma cubed, as sum of roots of the form alpha squared, which is 3, plus sum of roots here, which is 1, and is plus 15. So that's 3 plus 1 plus 15, and that's 19. And 19 is what they want us to prove for. So I'll say here, hence shown. Let's scroll down to part B. On part B, the question goes, find the value of alpha to the power 4 plus beta to the power 4 plus gamma to the power of 4. Now to answer this question, let us consider the original equation, and let's take this part where we had made z cubed subject. So we start from there. So we had z cubed being equal to z squared plus z plus 5. And what I'm going to do right here is multiply all the terms by z. So by z for each one. So that means we'll be having z to the power 4 being equal to z to the power 3 plus z squared plus 5z. So we can actually come out with a recurrence relationship for z to the power 4, which is sum of roots of the form alpha to the 4 being equal to sum of roots of the form alpha cubed plus sum of roots of the form alpha squared plus 5 of the sum of roots. And with that, for sum of roots of the form alpha cubed, that's like alpha cubed plus beta cubed plus gamma cubed, which we got right above as 19. So we can have 19 here, and it's plus sum of roots of the form alpha squared, which is alpha squared plus beta squared plus gamma squared. And we got that right above to be actually 3 here. So it's plus 3. And it's plus 5 of sum of roots, which is 1. So here we'll be having 19 plus 3 plus 5, which is 27. So that's what we get right here. Let's go on to part C. On part C, the question goes, find a cubic equation with roots alpha plus 1 plus beta plus 1 plus gamma plus 1, giving your answer in the form px cubed plus qx squared plus rx plus s equal to 0, where p, q, and r and s are constants to be determined. Okay, so for this one here, considering the form of the roots, we're going to use the method of substitution, and we'll say let x be equal to z plus 1. So we can make z subject, so z will be equal to x minus 1. So by substitution, we are going to substitute z into the original equation. Now the original equation is this one here, so let's just take it. So substituting z into the equation, we'll be having x minus 1 cubed minus x minus 1 squared, and it's minus x minus 1, and it's minus 5, and it's equal to 0. So we're going to simplify this, expanding the bracket, starting with x minus 1 cubed. X minus 1 cubed will give us x cubed minus 3x squared, and it's plus 3x, and it's minus 1. And it's going to be minus, expanding x minus 1 squared, that's x squared minus 2x plus 1. So that's minus x minus 1 and minus 5 equal to 0. So we can simplify this again to x cubed minus 3x squared plus 3x minus 1 minus x squared plus 2x minus 1 minus x plus 1 minus 5 equal to 0. And we can group the like terms. So we have x cubed. Then for terms in x squared, we have minus 3x squared minus x squared, which is minus 4x squared. Then 3x plus 2x, that's 5x, and 5x minus x gives us 4x. Then for the constants, we have minus 1 minus 1, which is minus 2. Then minus 2 plus 1 is minus 1. And minus 1 minus 5 is minus 6. And that's all equal to 0. So this equation here is the answer. Okay, that's the equation in terms of x, like this. So that means we are done with this question. We can scroll down to question number 5. Question 5 goes, the matrix A is given by A is equal to the 2 by 2 matrix with elements 5, k, minus 3, and minus 4. So on A, the question goes, find the value of k for which A is singular. Now we know that singular matrices have a determinant equal to 0. So in this case, since A is singular, we are saying the determinant of A should be equal to 0. Now, what is the determinant of A? We find that by multiplying 5 times minus 4, so 5 times minus 4, and it's minus k times minus 3, so k times minus 3 and we're going to equate that to 0. So we're going to get minus 20 and it's plus 3k equal to 0. So solving for k, we're going to get k coming out as 20 over 3. So that's the value of k for which a is singular. Let's scroll down to the next part. It is now given that k is equal to 6, so that a is equal to the 2 by 2 matrix with elements 5, 6, and minus 3 and minus 4. So on B, find the equations of the invariant lines through the origin of the transformation in the xy plane represented by A. So here, for the invariant lines, we are going to have the equation 5, 6, minus 3, minus 4 of xy being mapped onto the invariant image, which is x dash y dash. So multiplying the left hand side, we'll be having 5x plus 6y, and lower row and column will be having minus 3x minus 4y. So this is equal to x dash y dash. So here now we have two equations. 5x plus 6y is equal to x dash, and minus 3x minus 4y is equal to y dash. Now the line is passing through the origin, okay, and for that reason it should satisfy the equation y is equal to mx. And because of that, for these two equations that we have, we can actually substitute mx for y. So I'll rewrite the two equations. Okay, let's just label them. This is equation 1 and this is equation 2. So equation 1, when substituting mx in place of y, we'll be having it as 5x plus 6mx, and it's equal to x dash. Then for equation 2, substituting mx for y, then we'll be having minus 3x minus 4mx is equal to y dash. But now the image is going to be the same as the object since the line is invariant. So I'm going to say the line is invariant, so y dash should be equal to mx dash. So if we're saying y dash is equal to m of x dash, then we can use minus 3x minus 4mx for y dash, and it's equal to m, that's m, of x dash, and for x dash we're going to have 5x plus 6mx. So that'll be minus 3x minus 4mx is equal to 5mx plus 6m squared x. Now all the terms have x on them, so we can simply divide all the terms by x, such that we'll be having minus 3 minus 4m is equal to 5m plus 6m squared. So what I'll do right now is take everything to one side. So this will be equal to 6m squared, and then 5m plus 4m, that will be plus 9m. Then minus 3 to the other side becomes plus 3, and it's all going to be equal to 0. So now we can solve for m to get the possible values of m. So factorizing, we will get inside the bracket 6m plus 3 and m plus 1. So it's either 6m plus 3 that's equal to 0, where m will come out as minus a half, or m plus 1 is equal to 0, where m comes out as minus 1. So these are the two possible values of m. Now remember, the question wants us to find the equations of the invariant lines through the origin. And we know that these lines take the form y is equal to m of x. So when m is equal to minus a half, we know that the equation will be y is equal to minus a half of x. And when m has a value minus 1, then y will be equal to minus x. So these two here are the equations of the invariant lines through the origin. Let's scroll down to the last part, and that's part C. The triangle DEF in the xy plane is transformed by A onto triangle PQR. Given that the area of triangle DEF is 10 square centimeters, find the area of triangle PQR. Okay, so from the information here given, we can see that triangle DEF is being mapped onto triangle PQR. So that's by the matrix operator A. And the original area of triangle DEF is 10 square centimeters. So they want us to find the area of triangle PQR. So we know the fact that the area of the image, which in this case is triangle PQR, should be equal to the determinant, and it has to be the absolute value of the determinant of, in this case, the matrix operator A, and it's times the area of the object, and the object in this case is triangle DEF. Now the determinant of A is the matrix with elements 5, 6, minus 3 and minus 4. So let's just take it here and paste it here. So the determinant of A is actually 5 times minus 4, which is minus 20, and it's minus 6 times minus 3, which is minus 18. So it becomes plus 18. So that's minus 2 for the determinant of A. So here, for the absolute value of the determinant of A, we'll be having 2 times area of DEF, which is 10. So the area of triangle PQR should be 20 square centimeters. So that's the answer to part 1. Let's go down to part 2. Now on part 2, find the matrix which transforms triangle PQR onto triangle DEF. Now for this one, we are looking for the matrix that takes triangle PQR back to triangle DEF. So if the matrix operator A transforms triangle DEF onto triangle PQR, then A inverse should do the reverse. It should transform triangle PQR to triangle DEF. So what's required of us here is to find A inverse. So for A inverse, it is equal to 1 over the determinant, which is minus 2, of, and here we are going to switch positions for 5 and minus 4. So we are going to have minus 4 here and 5 here, and change signs or multiply 6 and minus 3 both by minus 1, each by minus 1. So we'll be having minus 6 here and 3 here. So that's A inverse, and we can just simplify this to multiplying minus a half into the bracket. We'll be having 2 and 3 and minus 3 over 2 here and minus 5 over 2. So that's what we get as the answer, and we are done with question number 5. Question number 6. The position vectors of the points A, B, C, D are 2i plus 4j minus 3k, minus 2i plus 5j minus 4k, I plus 4j plus k, I plus 5j plus mk, respectively, where m is an integer. It is given that the shortest distance between the line through A and B and the line through C and D is 3. So on A, show that the only possible value of m is 2. Okay, so let's make use of the information given. Here we're talking about a line through A and B. So let's find the vector equation of this line. So that's a line through A and B. Now I prefer to use column vector form. So the vector equation of the line will be r is equal to, and we take the coordinates of a point on the line which is A. So in column vector form, that's 2, 4, minus 3, and it's plus lambda, and that's of the direction vector of AB. So AB is OB minus OA, which gives us minus 4, 1, and minus 1. So this is the vector equation of the line through AB. Now we also have in the question the line through C and D. So let's have line through C and D. Now the vector equation of this line will be r is equal to, and we take the position vector of any point on the line. Let's take C. So the coordinates of C are 1, 4, 1 in column vector form. So that's 1, 4, 1, and it's plus mu of the direction vector of CD. So that CD is equal to OD minus OC, and that's going to give us 0, 1, and m minus 1. So we now have the two vector equations of the lines. Now according to the question, we are looking for the shortest distance between the two lines. And for the shortest distance between two lines, we can use this formula here. So for this formula, we are going to need first to find A2 minus A1. So A1 and A2 are the position vectors of points on the lines. So in this case, that will be 1, 4, 1 minus 2, 4, minus 3. And when we subtract the 2, we are going to get 1 minus 2, that's minus 1, 4 minus 4, that's 0, and 1 minus minus 3, which is 4. So this is A2 minus A1. Next, we shall need to find the cross product of B1 and B2. Now, B1 and B2 are the direction vectors of the two lines. So that's the cross product of the direction vector of the line through A and B. So minus 4, 1, and minus 1. And we are cross multiplying that with the direction vector of the line through C and D, which is 0, 1, and m minus 1. So we can find it this way, where we are going to have minus 4, 1, and minus 1, then 0, 1, and m minus 1. So this is going to be equal to, closing out I, then we'll be having 1 minus 1, 1, and m minus 1, and that's I, and it's going to be minus, and closing out J, we'll be having minus 4, minus 1, 0, and m minus 1 remaining. So that's J. And for the last one, we close out K. So that will be plus, and we'll be having minus 4, 1, 0, 1, and that's K. So we can simplify this. Here we're going to say 1 times m minus 1, which is m minus 1, and it's minus 1 times 1, so it becomes plus 1, and it's all for I, and it's minus. Here we'll be having minus 4 times m minus 1, which is like 4 minus 4m, and minus 1 times 0 is 0, so we have J here, and it's plus. Here we are going to have minus 4 times 1, which is minus 4, and it's minus 1 times 0, which is 0. So that's for K. Okay, so if we simplify this, we'll be having mi, and this can be written as plus 4m minus 4, and that's J, and that's minus 4K. So this is what we get for the cross product of B1 and B2. So now we can apply the formulas. So we're saying the perpendicular distance will be equal to, and here we're going to take A2 minus A1, which is minus 104. So let's have that. So minus 104, and it's dot, and we take B1 cross B2, which we got to be this here. So that's M, 4M minus 4 and minus 4 here. And that's going to be O over the square root of M squared plus 4M minus 4, and it's plus minus 4 squared. And according to the information in the question, they say that the shortest distance here is 3. So we're going to equate this to 3. So for the dot product here, we're going to multiply minus 1 times M to get minus M, and 0 times 4M minus 4, so that's 0. Then 4 times minus 4 is minus 16. And for the denominator here, we're going to multiply it to both sides, which means it will come on the right side, and we'll be having 3 of the square root of M squared plus, so we're supposed to have a squared here. I think we left it out. So that's plus 4M minus 4 squared, and that's plus minus 4 squared. So here we'll be having minus M minus 16 is equal to 3 times the square root of, and now we simplify this, so that will be M squared, and it's plus, expanding 4M minus 4 squared, that will be 16M squared, and it's minus 32M, and it's plus 16, and here minus 4 squared is 16. So we can continue simplifying. So we have minus M minus 16 is equal to 3 of the square root of, in this case, M squared plus 16M squared is 17M squared, and it's minus 32M, and it's plus 16 plus 16, that's 32. So we can now square both sides. So if I square this side, I'll be having minus M minus 16 squared. And on the right side, 3 squared is 9. And if we square this radical, we'll be having 17M squared minus 32M plus 32. Now, if we expand minus M minus 16 squared, we are going to get M squared plus 32M plus 256, and it's equal to 9 times 17 M squared gives us 153 M squared, and 9 times minus 32 is minus 288 M, and 9 times 32 is 288. So we'll be left with a 0 on the left side, and that'll be equal to, so that'll be 152 M squared. And subtracting 32 from both sides, we'll be having here minus 288M minus 32, which gives us minus 320M. And then subtracting 256 from both sides is 288 minus 256, which is 32. So it's plus 32. So that's what we get right here. So we can actually divide all the terms by 8. So that's all the terms by 8. And we are going to have 19M squared minus 40M plus 4 equal to 0. Now with what we have, we are going to solve for M. So here, if we factorize this, we are going to get 19M here and M here, and then minus 2 and minus 2. So the possible values that M can take are M is equal to 2 over 19, or m is equal to 2. Now, according to the question here, m is an integer. So we are going to take the integer value of m. So we're going to say, therefore, since m is an integer, so m should have the value 2. And that's what they wanted us to show, that the only possible value of m is 2. So I'm going to say here, hence shown. Let's scroll down to part B. On part B, the question goes, find the shortest distance of D from the line through AC. So here it's like we've got a line which is passing through A and C, and we're looking for the shortest distance of the point D from that line. So shortest distance means perpendicular distance, so we actually are looking for this distance here, which I want to call D. So there should be a right angle between these two lines. So in order for us to find this distance, I will start by finding the vector equation AC. So we're saying the line through A and C is the line R is equal to, and we take the position vector of any point on the line. So we can either take A or C. So let's take A. And from the question, A is this vector here, which is 2, 4, minus 3 in column vector form. And it's going to be plus, and I'll use the letter T here. The direction vector of AC, which is OC minus OA, and that's going to give us minus 1, 0, 4. So this is the equation of the line through AC. Now, let us consider this point here, which I want to call P. So we can find the coordinates of P using the equation of the line. So I can say let T be equal to T naught at P, which therefore means that the position vector of P will be equal to, just combining this, 2 minus T, and then 4 plus 0T, so that's just, and minus 3 plus 4T here, so that's minus 3 plus 4T. So we now have the position vector of the point P, which means that we can now find the vector PD. So let's find PD. So we're saying PD is equal to OD minus OP. Now OD is this vector here, and we got M to be 2, so it will be just in column vector form 1, 5, 2. And it's minus OP, which is this vector here, 2 minus T, 4, and minus 3 plus 4T. So we can find PD here. That's 1 minus 2 minus T, which gives us minus 1 plus T. Then 5 minus 4, that's 1. Then 2 minus 3 plus 4T, which will become 5 minus 4T. So this is what we are going to get for PD. Now PD is perpendicular to AC. So let's write that down. So it's saying since PD is perpendicular to AC, then we can do dot product, because we know that perpendicular vectors have their dot product equal to 0. So we're going to do the dot product of PD, which we got to be minus 1 plus T, 1 and 5 minus 4T, and its dot. AC, the direction vector of AC is what we got right here to be minus 1, 0, 4. So we have minus 1, 0, 4 here. So this should give us 0. So for the dot product, we multiply minus 1 plus T by minus 1, and that's going to give us 1 minus T. And then 1 times 0 gives us 0. Then 4 times 5 minus 4T will give us, that's plus 20 minus 16t, and that's all equal to 0. Now, minus t minus 16t is minus 17t, and 1 plus 20 is 21, and if we cross it over to the other side, we get minus 21, so t comes out as 21 over 17. So we now have the value of t, and now we can find the length d, which is the shortest distance of d from the line through A and C. So d is the same as PD here. So let's have that. So we are saying here d is equal to PD, or the modulus of the vector PD. Now the vector PD is what we got right above here. That's minus 1 plus t, 1 and 5 minus 4t. So let's have that. So that's minus 1 plus t, 1 and 5 minus 4t. And since we got t to be 21 over 7, it will be equal to minus 1 plus 21 over 17. That's 17, and that's 1. Then 5 minus 4 of 21 over 17. So that is going to come out as minus 1 plus 21 over 17 is 4 over 17. Then we have 1. Then 5 minus 4 of 21 over 17 is 1 over 17. So to find the modulus of PD, that will just be the square root of 4 over 17, and that's squared, plus 1 squared plus 1 over 17 all squared. So using our calculator, that will be the square root of, that's 4 over 17, and that's squared, and it's plus 1 squared, and it's plus 1 over 17, and that's all squared again. And that's going to give us 1.028, which is 1.0323 as f. So we get the answer as 1.03. So that is the perpendicular distance we're looking for. Let's scroll down to part C. On part C, the question goes, show that the acute angle between the planes ACD and BCD is arc cos of 1 over root 3. Now to find the angle between two planes, we can use this formula here. So what we're going to need are the normals. So firstly, the normal to the plane ACD. So for this one, we'll need to find AC and CD. Now AC, we got it already right above on part B as the direction of the line through A and C. So that's minus 104. So we have minus 104 here. Then CD, for CD, I'm sure we already have it again. That's on part A when we did the line through C and D. So it came out to be 0, 1 and m minus 1. And since m is 2, so it will be 0, 1 and 2 minus 1, which is 0, 1, 1. So that's CD. So that's 0, 1, 1. So for the normal to the plane that contains this 2, we are going to do the cross product for AC cross CD. So that's equal to minus 104 cross multiplying 0, 1, 1. So that's equal to, so here I'll cross out minus 1 and 0. So 0 times 1 is 0, and it's minus 1 times 4, which is minus 4. Then crossing out 0 and 1, I have minus 1 times 1, which is minus 1. And it's minus 0 times 4, which is 0. So we get minus 1, but there has to be a minus on it. So it just comes out as 1. Then we close out the last set of numbers. So minus 1 times 1 is minus 1, minus 0 times 0, which is 0. So this is the cross product of AC and CD, which also happens to be the normal to the plane ACD. Next, we'll need to find the normal to the plane BCD. So for this one, we will need to find the vector BC and also the vector CD. Now for BC, we can say that's OC minus OB. Now OC is the vector 1, 4, 1, and its minus OB is the vector minus 2, 5, and minus 4. So here we are supposed to get 3 minus 1, and 1 minus minus 4, that's 5. Then for CD, that's OD minus OC. So that's OD is 1, 5, 2, and it's minus OC, which is 1, 4, 1. So 1 minus 1 is 0, 5 minus 4 is 1, and 2 minus 1 comes out as a 1. So now we can find BC cross multiplying vector CD. Now BC is the vector 3 minus 1, 5, and it's cross multiplying 0, 1, 1. So for this, we are going to get, closing out this first two, we're going to get minus 1 times 1, which is minus 1, and it's minus 1 times 5, which is 5. So it's like minus 1 minus 5, which is minus 6. So we have minus 6. And closing out the middle terms, 3 times 1, that's 3, and it's minus 0 times 5, which is 0. So 3 minus 0 is 3, but there's a minus on it, so it's just minus 3. Then closing out this, we have 3 times 1, which is 3, and it's minus 0 times minus 1, which is 0. So 3 minus 0 is 3. So this is what we get for the normal to the plane BCD. So now that we have the two normals, we can now apply the formula. So we're saying here, cos theta is equal to the normal to the first plane. We got that to be minus 4, 1, and minus 1. So that's minus 4, 1, and minus 1. And it's dot the next normal, which is the normal of the plane BCD, which we got to be minus 6, minus 3, and 3. And that's going to be O over, and here we'll be having the modulus of the first vector. So that's the square root of minus 4 squared plus 1 squared plus minus 1 squared, and it's times the square root of minus 6 squared plus minus 3 squared plus 3 squared. So here we can simplify the dot product right above. Minus 6 times minus 6 is 24. Then 1 times minus 3 is minus 3. Then minus 1 times 3 is again minus 3. And that's over. Here we'll be having the square root of 4 squared plus 1 squared plus 1 squared. That's 18. And it's times here 6 squared plus 3 squared plus 3 squared. That's 54. So that's square root of 54. So basically we have 18 over the square root of 18 times square root of 54. So we can multiply numerator and denominator by root 18. And if we do that on the numerator, we'll be having 18 root 18, and that's over root 18 times root 18 is 18. So it's 18 root 54. So it means we can cancel out the 18s right here. So we now have root 18 over root 54. So what we have here is the same as the square root of 18 over 54. Now 18 over 54 is a third. So it's as good as we have 1 over root 3. So that's all equal to cos theta. So therefore, theta should be equal to arc cos of 1 over root 3. And this will be the final answer. Question number 7. The curve C has the equation y is equal to 2x squared minus 3x minus 2 O over x squared minus 2x plus 1. On A, state the equations of the asymptotes of C. So we're going to start with the vertical asymptote. And for the vertical asymptote, I'm going to set the denominator to 0. So x squared minus 2x plus 1 equal to 0. This is x minus 1 squared equal to 0. And we get that x is equal to 1. So this is the equation of the vertical asymptote. For the horizontal asymptote, we know that we have a horizontal asymptote because the degree of the numerator is equal to the degree of the denominator. And for the horizontal asymptote, it will be y is equal to, so we just consider the coefficients of the leading terms for both the numerator and denominator, where we have the coefficient for the numerator of x squared being 2 and the coefficient of x squared on the denominator as 1. So the equation of the horizontal asymptote will be y is equal to 2 over 1, which is y is equal to 2. So these are the two equations for the vertical asymptote and for the horizontal asymptote. Let's go on to part B. On part B, the question goes, show that y is less than or equal to 25 over 12 at all points on C. So the key thing here is we're talking about all points on the curve C, which means these are real values. So what we're going to do is we're going to try to come out with the quadratic equation so that we use the discriminant to determine the values of y that are on the curve C. So I'm going to multiply both sides of the equation by the denominator. So I'll be having y of x squared minus 2x plus 1. And that will be equal to 2x squared minus 3x minus 2. Now I'll simplify. On the left side, we'll be having x squared y minus 2xy plus y. And that's equal to 2x squared minus 3x minus 2. Now I'm going to take everything that's on the right side to the left side. And grouping the terms, I'll be having x squared y minus 2x squared. Then minus 2xy, and that's plus 3x. Then y plus 2, and that's all equal to 0. Now I'm going to factor out x squared for the first two terms. So I'll be having y minus 2 of x squared here. And for the next two terms, I'll factor out x. So it'll be plus 3 minus 2y of x, like this. And for the last two terms, I'll just write them as y plus 2, like this. Now, if you look at what we have, we now have kind of like a quadratic equation in x. And since we're talking about points on the curve C, then we know that the discriminant b squared minus 4ac should be greater than or equal to 0. Now this is A, this is B, this is C. So for the discriminant, it'll be b squared, which is 3 minus 2y all squared, and that's minus 4 of y minus 2 of y plus 2, and that is greater than or equal to 0. Now let's simplify this. Expanding the brackets, we'll be having 9 minus 12y, and that's plus 4y squared, and that's minus 4 of, and here for y minus 2 multiplying y plus 2, that's a difference of 2 squares, y squared minus 4, and that's greater than or equal to 0. So that's 9 minus 12y plus 4y squared minus 4y squared plus 16 is greater than or equal to 0. Now here 4y squared minus 4y squared is 0. Then 9 plus 16 is 25. Then minus 12y is here. So we'll be having it like this. And I can subtract 25 from both sides. So minus 12y is greater than or equal to minus 25. And if we divide both sides by minus 12, then the sign is going to reverse, and on the left side we'll be having y, and on the right side we'll be having minus 25 over minus 12, which is 25 over 12. And this is what they want us to get according to the question. So here I'll say hence shown. Let's go on to part C. On part C, the question goes, find the coordinates of any stationary points of C. Now, we know that at the stationary points, dy by dx is equal to 0. So we're going to differentiate the equation of the curve here. I'm going to take the denominator, which is x squared minus 2x plus 1, and I'll multiply that with the derivative of the numerator, which happens to be 4x minus 3. And that's going to be minus, and I'll have the numerator 2x squared minus 3x minus 2, multiplying the derivative of the denominator, which will give us 2x minus 2. And that's O over the denominator squared, so that's x squared minus 2x plus 1 squared, and that's all equal to 0. Now we can simplify the numerator. Expanding the brackets, I'll multiply x squared by the second bracket here, so I'll be having 4x cubed minus 3x squared. Then I'll multiply minus 2x by the second bracket, so that'll be minus 8x squared, and that's plus 6x. Then I'll multiply 1 by the second bracket to get plus 4x minus 3. Then I go to the next two brackets. I multiply 2x squared by the second bracket, so I'll be having 4x cubed minus 4x squared. And then minus 3x by the second bracket will be minus 6x squared, and that'll be plus 6x. And then minus 2 multiplying the second bracket, I'll be having minus 4x plus 4, and that's all equal to 0. Now the denominator gets eliminated by multiplying it to both sides, so we are okay like this. So now we have 4x cubed, and minus 3x squared minus 8x squared is minus 11x squared. Then 6x plus 4x is 10x, and it's minus 3, and it's minus, inside the bracket we have 4x cubed, then minus 4x squared minus 6x squared is minus 10x squared. 6x minus 4x is 2x, and it's plus 4, and it's all equal to 0. Now simplifying again, 4x cubed minus 4x cubed is 0. Minus 11x squared minus 10x squared will give us minus x squared. 10x minus 2x is 8x. Then minus 3 minus 4 is minus 7, and it's all equal to 0. So this is what we get. Now, if we divide all the terms by -1, we'll be having x squared minus 8x plus 7 equal to 0. And this can be simplified. And if we factorize this, we get x minus 7, x minus 1 within the brackets, which therefore means that x comes out equal to 7, or x comes out being equal to 1. Now for x is equal to 1, if we go back to part A, we got that x equal to 1 is an asymptote to the curve, which means the graph does not exist for x is equal to 1. So we don't have this value. So the turning point will be at x equal to 7. And we also need to know what the value of y is when x is equal to 7. So we can substitute 7 into the equation of the curve. So I'll use a calculator for that. So I'm going to store 7 into x. So it's 7 shift store into x. Then I'll type in the fraction So that's 2x squared minus 3x minus 2. So that's 2 alpha x squared minus 3 alpha x minus 2. And on the denominator, we have x squared minus 2x plus 1. So that's alpha x squared minus 2 alpha x, and it's plus 1. And what we get here is 25 over 12. So I've just substituted 7 in place of x in the equation, and I got y coming out as 25 over 12. So y is 25 over 12. So the turning point, or the stationary point, is the point 7 and 25 over 12. So this is what we will get. Let's scroll down to part D. On part D, the question goes, sketch C stating the coordinates of any intersections of C with the coordinate axis and the asymptotes. Okay, so for this one here, we will need the following information. First of all, on part A, we got the equations of the asymptotes. So for the asymptotes, we got them in part A as x equal to 1 for the vertical asymptote and y is equal to 2 for the horizontal asymptote. So let's have those. So we have x is equal to 1 and y equal to 2. Now the other important information is that of the stationary point. And on part C, we got the coordinates of the stationary point. So we got that as 7 and 25 over 12. So that's the coordinates of the stationary points, 7 and 25 over 12. Again, we are going to need to consider the intercepts. Now, for the intercepts, we can start with the y-intercept, and the y-intercept occurs when x is equal to 0. And when x is equal to 0, substituting that into the equation, we get that y comes out as minus 2. And for the x-intercept, it occurs when y is equal to 0. And when y is equal to 0, we need to find the values of x right there. Now, considering the equation, when y is equal to 0, then this equation 2x squared minus 3x minus 2 equal to 0 is satisfied. So we need to solve for x from this equation. So we can quickly do that using our calculator. So I'll go to mod and equation 5 and quadratic, that's option 3. So for this equation here, I'll store 2 for A, and I'll store minus 3 for B, and I'll store minus 2 for C. So here I can get the value of x. So the first value of x comes out as 2. So x is equal to 2, and the other value will come out as minus a half. So we also have minus a half here. So the coordinates of the intercepts are, for the y-intercept, 0 and minus 2. And for the x-intercepts, we have the points 2, 0, and we also have minus a half and 0. So with this information, we can now make the sketch. So we start with the x's, and here I'm going to have the asymptotes. X is equal to 1 and y is equal to 2. So this is the vertical asymptote. So we have a 1 here. Then the horizontal asymptote is y is equal to 2. So here it is. And it intercepts the y-axis at 2. Now we need to consider the behavior of the graph about the asymptotes. So let's start with the behavior of the graph about the vertical asymptote, x is equal to 1. And for that, I'll take a value that is slightly less than 1 and one that is slightly greater than 1 and see where the graph will be at. So for a value that is slightly less than 1, I'll take a value 0.999 and substitute that into the equation. And when I do that, I get that y comes out minus 3 million, which is a very small y value. So the graph will be coming out from down below. and then I take a value that is slightly greater than 1. Here I'll take the point x equal to 1.001, and for this value, substituting it into the equation, I get that y comes out as minus 2 million, which again is a very small y value, so the graph will be coming out from again down below here. Next, I'll need to consider the behavior of the graph as x becomes significantly small. So for a very small value of x, I'll use x equal to minus 1000 and substitute that into the equation. And if we do that, we get that y comes out as 1.999, which is slightly less than 2. So the graph will be coming out from slightly below the horizontal asymptote. And I'll also need to consider the behavior of the graph as x becomes significantly large, that is, as x approaches positive infinity. And for this, I'll use x equal to 1000 as a large value of x and substitute it into the equation. And when I do that, I get y coming out as 2.001, which means the graph is slightly above the line y is equal to 2. So it will be coming out from just right here, above the line y is equal to 2. So I now have an idea of how the graph is gonna be like, so I can attempt to make the sketch. So what I'll do is I'll start with this tail, which should be somehow like this, and again the other tail will be coming on the other side, and it should be like this. So this is how my graph will be like. So we have intercepts. With the y-axis, it intercepts at minus 2. With the x-axis, it intercepts here at minus a half, and also at 2. So the point 2 will be right here. And also it has a turning point round about here. So our graph is reflecting that as well. So this is how I would sketch the graph. Let's scroll down to part E. On part E, the question goes, sketch the curve with the equation y is equal to mod of 2x squared minus 3x minus 2 over x squared minus 2x plus 1, and find the set of values of x for which the modulus of the function is less than 2. So let's start with sketching the modulus graph. So for this, I'll need the original graph that we drew on part D. So I'm going to paste it here. And for the modulus graph, we reflect the part of the graph that is below the x-axis in the x-axis. So I'll start with this lower tail that is to the left, and I'll reflect it in the x-axis. So to do that, it should come out like this. So this is how it will come out like. And then I'll also reflect this other lower tail to the right in the x-axis. So it'll come out like this. So I'm going to remove the part of the graph that is below the x-axis. So here we go. This is the modulus graph. So here we've got a 0, here we've got a 1, here we've got a 2, and here we have a minus a half. So this is how the modulus graph will come out like. Now we want to answer the last part of the question, which goes, find the set of values of x for which the modulus of the function is less than 2. Okay, so we're going to use the graphical method to find this set of values. And for that, we're going to need to know the x values of these 3 critical points. So in order for us to do that, we have to consider the line y is equal to 2, which is this horizontal line. That's the one that's intercepting the graph at these critical points. So let's find the intercepts. First of all, these 2 points are intersecting the line y is equal to 2 at the portions of the graph that were reflected when we were making the modulus graph. So these are reflected portions of the graph. So I'll write them as y is equal to minus of 2x squared minus 3x minus 2, and that's over x squared minus 2x plus 1. and that's where it intercepts the line y is equal to 2. So we are going to solve for x for this. And for this third point, this is where the graph of 2x squared minus 3x minus 2 over x squared minus 2x plus 1 intercepts the line y is equal to 2, like this. So these are the two equations we're going to solve to get this 3 points. Okay, so let's start with the first one. Multiplying both sides by the denominator, we'll be having minus of 2x squared minus 3x minus 2 being equal to 2 of x squared minus 2x plus 1. So that's minus 2x squared plus 3x plus 2 being equal to 2x squared minus 4x plus 2. Now we're going to take everything on the left side to the right side. So we'll be having 0 here. Then 2x squared plus 2x squared is 4x squared. Then minus 4x minus 3x is minus 7x. Then 2 minus 2 is 0. So this is the equation here. And we can factor out x to get 4x minus 7. So it's either x is equal to 0 or 4x minus 7 equal to 0. So x comes out as 7 over 4. So we now have the values of x here. So x is equal to 0 is this point here. And x is equal to 7 over 4 is the x value of this point here. Now let's solve the other equation. Multiplying both sides by the denominator, we'll be having 2x squared minus 3x minus 2 being equal to 2 of x squared minus 2x plus 1. So here we'll be having 2x squared minus 3x minus 2 being equal to 2x squared minus 4x plus 2. So subtracting 2x squared from both sides, then we get 0 for these. Then if we take what's on the right side to the left side, we'll be having minus 3x minus 2, and that's plus 4x minus 2, and that's equal to 0. Now minus 3x plus 4x is x. Then minus 2 is minus 4, and that's equal to 0. So x is equal to 4. So it means for this point here, x is equal to 4. So we now have the critical points. And now we can solve the inequality. So we are saying here, we are looking for the values of x that are such that the modulus graph is less than 2. So these are the values of x for which the modulus graph is below the graph y is equal to 2. So first of all, considering this critical point, then the graph of the modulus function is below that of y is equal to 2 for all values of x that are less than 0. That's when the graph is below the graph of y is equal to 2. So that's the first inequality. So my first solution is x is less than 0. And next, the other part of the graph that is below the graph y is equal to 2 is between this point and this point here. That's where the graph is below or less than that of y is equal to 2. So it's between this point, x equal to 7 over 4, and this point which we got to be a 4. So the inequality will be from 7 over 4 to 4. So this 2 here are the two solutions. And that's how we do it.